Hi folks, I am Professor Dr. Riaz, working as a professor in the Department of Computer Science and IT, as well as working as a Director ORIC of Mirpur University of Science and Technology. Today I am going to deliver you a very much important lecture on the industry, innovation and infrastructure. This belongs to the SDG 9, which was adopted by United Nations. Today I am going to discuss with you different details of the industry, and then I will discuss with you about innovations and infrastructures. Why this topic is very much important? Because nowadays all the businesses are relying on these three things. So these three things are the three pillars of the whole world's businesses. Thank you. The Sustainable Development Goals are a universal call to action to end poverty, protect the planet, and improve the lives and prospects of everyone, everywhere. The 17 goals were adopted by all UN member states in 2015 as part of the 2030 Agenda for Sustainable Development, which set out a 15-year plan to achieve the goals. The main aim of SDG 9 is to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. To achieve this goal, there is a need to construct new, greener infrastructures, retrofitting or reconfiguring existing infrastructure systems, and exploiting the potential of smart technologies. It can greatly contribute to the reduction of environmental impacts and disaster risks, as well as the construction of resilience and the increase of efficiency in the use of natural resources. Now we shall discuss the targets of SDG 9. First target is to develop quality, reliable, sustainable, and resilient infrastructure, including regional and trans-border infrastructure to support economic development and human well-being with a focus on affordable and equitable access for all. Second target is focused to promote inclusive and sustainable industrialization by 2030, significantly raise industry's share of employment and gross domestic product, in line with national circumstances, and double its share in least developed countries. Third target is to increase the access of small-scale industrial and other enterprises, in particular in developing countries, to financial services, including affordable credit and their integration into value chains and markets. By 2030, UN is focused to upgrade infrastructure and retrofit industries to make them sustainable with increased resource use efficiency and greater adoption of clean and environmentally sound technologies and industrial processes, with all countries taking action in accordance with their respective capabilities. The fifth target is to enhance scientific research, upgrade the technological capabilities of industrial sectors in all countries, in particular developing countries, including by 2030, encouraging innovation and sustainability, increasing the number of research and development workers per 1 million people, and public and private research and development. Another important target is to facilitate sustainable and resilient infrastructure development in developing countries through enhanced financial, technological, and technical support to African countries, least developed countries, landlocked developing countries, and small island developing states. Moreover, the UN is willing to support domestic technology development, research, and innovation in developing countries, including by ensuring a conducive policy environment for inter alia industrial diversification and value addition to commodities. The last target is to significantly increase access to information and communication technology and strive to provide universal and affordable access to the internet in least developed countries by 2030. Here we shall discuss the problems which needs attentions to be resolved. Number one, it has been reported that the small-scale industries lack access to financial support for recovery, and only 1 in 3 small manufacturers are benefiting from a loan or the line of credit. 1 in 3 manufacturing jobs are negatively impacted by the crisis. Furthermore, the passenger airline industry is still struggling to recoup catastrophic losses of 2.3 billion, whereas 4.5 billion passengers were recorded in 2019 compared with 2.3 billion in 2021. Moreover, the global manufacturing has rebounded from the pandemic, but LDCs are left behind. As you can see from the graph of manufacturing growth, that LDCs could not recover from the pandemic loss, while rest of the world has got back to the normal routine. Besides, the higher technology industries are far more resilient in crisis than their low-tech counterparts. According to the website of UNDP, 2.3 people lack access to sanitization. 2.6 billion people in developing countries do not have access to constant electricity. In some low-income African countries, infrastructure constraints cut businesses' productivity by around 40%. In developing countries, barely 30% of agriculture products undergo industrial processing compared to 98% high-income countries. More than 4 billion people still do not have access to the internet. 90% of them are in the developing world. Here we shall discuss the connection of SDG 9 with other SDGs. The SDG 8, decent work and economic growth, is like SDG 9 because when the infrastructure, innovation, and industry are smoothly progressing, the economy will be good and our country and its people will all make money. Next, moving on to the industrial revolutions, we first need to understand what an industry actually is. An industry is a group of companies that are related based on their primary business activities. And the Industrial Revolution has changed the world forever. The Industrial Revolution was the transition from creating goods by hand to using machines. According to some, this turning point in history is responsible for an increase in the living standards and the emergence of the capitalist economy. Next, I would like to elaborate the 5 stages of Industrial Revolution. Stage 1. In the first stage, the use of water and steam-powered machines in production pushed Britain's economic development from 1750 to 1850. Built more than 100 years ago, this steam engine still powers the Queen's Mill textile factory in Burnley, England, United Kingdom. Stage 2. The second industrial revolution, also known as the technological revolution, was a phase of rapid scientific discovery, standardization, mass production, and industrialization from the late 19th century into the early 20th century. Advancements in manufacturing and production technology enabled the widespread adoption of technological systems such as telegraph and railroad networks, gas and water supply, and sewage systems, which had earlier been concentrated to a few select cities. Stage 3. The third industrial revolution began in the 70s in the 20th century through partial automation using memory, programmable controls, and computers. Since the introduction of these technologies, we are now able to automate an entire production process without human assistance. Known examples of this are robots that perform programmed sequences without human intervention. Stage 4. The fourth industrial revolution is characterized by the application of information and communication technologies to industry and is also known as Industry 4. It builds on the developments of the third industrial revolution. Production systems that already have computer technology are expanded by a network connection and have a digital twin on the internet, so to speak. These allow communication with other facilities and the output of information about themselves. This is the next step in production of automation. The networking of all systems leads to cyber-physical production systems and therefore smart factories in which production systems, components, and people communicate with a network and production is nearly autonomous. While companies and whole industries are still in the middle of this fourth revolution, the next revolution is already well on its way. Industry 5. Before you panic and try to make hasty decisions, let's have a quick run through. The concept of Industry 5 is a relatively new one and it is aimed at supporting but not superseding humans and finding the optimal balance of efficiency and productivity. According to the European Union, Industry 5 provides a vision of industry that aims beyond efficiency and productivity as the sole goals and reinforces the role and the contribution of industry to society. And it places the well being of the worker at the center of the production process and uses new technologies to provide prosperity beyond jobs and growth while respecting the production limits of the planet. It complements the Industry 4 approach by specifically putting research and innovation at the service of the transition to a sustainable, human centric, and resilient European industry. Next comes innovation, which is all about thinking big and comes from joining creativity with commercialization. Today, the term innovation is exclusively used in a business context. It is usually characterized as being something entirely novel, technology based, and causing positive impact on the world. But innovation is much broader concept than that and comes in many different forms. So, what exactly is innovation? The term innovation was popularized in the late 19th century by French sociologist Gabriel Trade as novelty but with no explicit definition. Victor Thompson in 1965, the generation, acceptance, and implementation of new ideas, processes, products, or services. In simple words, innovation is concerned with the creation and pursuit of new ideas, but new ideas don't have to come from nowhere. The innovation challenge all starts from the generation of creative ideas. The ideas are then collaborated with the team members and compiled for scientific evaluation. Then starts the testing and development of the idea, and the ideas are implemented to evaluate the desired outcomes. After all the stages, the review is the most important step, which helps to assess if the results align with the initially generated idea or not, and if further improvements can be done to make the developed proved market compatibility.
Number 1. Artificial intelligence. Yep, we promised we'd give you robots, and we don't like to disappoint. The robots we're talking about don't look like the ones from Star Wars. Lots of them, like Alexa and Siri, you can't even see because they're a computer program. What makes them robots is the fact they can take data, analyze it, and learn from it, and keep on getting more intelligent. Or the ones on Google and Facebook that figure out what ads they should make pop up on your screen. And for when you actually leave your living room, robots are already helping us build stuff in factories, analyze financial reports, act as virtual nurses for patients. In the future, we could be talking about robots we have in our houses that will be able to cook for us, do all kinds of boring jobs. And outside of our houses, doing dangerous ones like fighting fires or picking up radioactive waste. And a whole load of other things we'll get into later in the video. That's because AI is already combining with pretty much every recent technology, and it's only going to keep on doing that. Number 2. Brain-computer interfaces. Imagine being able to control a computer mouse and a keyboard or a drone with not a set of controls, but just by thinking about it, or hearing music not from speakers, but that's being streamed straight into your brain. Maybe that thought blows your mind, or perhaps it even creeps you out. Either way, it's already being developed and it's coming soon. And leading the way is Elon Musk's company Neuralink, which is looking at ways to implant a chip into your brain that will be able to communicate with computers. And just in case you thought we made the thing up about streaming music directly to your brain, that actually came from a tweet on Elon Musk's Twitter feed. If the thought creeps you out a bit, you're not alone, but the idea behind it is to help humans compete with super intelligent robots, and it also aims to cure disorders like depression and addiction by rewiring brain patterns. Number 3. 3D printing. But Alex, this is old news. Well, yes, but it's about to go to a whole new level. Of course, we're not just talking about those craft videos that come up on your Facebook feed with decorations people have made with 3D printing. 3D printing fashion accessories, even car parts, is kinda old school now. More cutting edge are 3D printed organs that use patient cells, which will mean they don't have to wait for an organ donor. In China, they've 3D printed an entire apartment block, and the future of 3D printed buildings could bring down the price of housing and solve the problem of homelessness. Also, 3D printed rockets could be on the way too. NASA's already made a 3D printed rocket injector, and a California-based company, Relativity Space, aims to make the first fully 3D printed space rockets for a fraction of what they cost now. And by throwing a bit of AI into the mix, the technology will be able to detect faults in the design and improve on them. But they're not there yet. First, they need to figure out how to 3D print something that's 100 feet tall and out of a material that can withstand the temperatures of takeoff. Number 4. Living robots. Next, a completely different kind of robot. No, not one that's so cute it makes you think it's alive. If you remember Tamagotchis, we're not talking about those. These so-called living robots are made of a real living tissue and could revolutionize medicine. Scientists have taken stem cells from frogs, and they've used computer programs to assemble them into blobs, about 1 millimeter in diameter. They're not robots as we know them, and even though they come from living tissue, they're not classed as animals either. They're tiny, programmable organisms that can move independently and can even work together as a team. They might even be able to self-heal their wounds, remove plaque from human arteries, or take medicine into patients' bodies. It's fascinating stuff. Number 5. Augmented reality. If you've played Pokemon Go, you've already used AR, but chasing Pokemon is just the tip of the iceberg with this exciting technology, and the boundaries are just going to keep growing. Overlaying digital images onto real-life backgrounds could have all kinds of applications in the future, like AR manuals. Think of the last time you had to fix a car engine but weren't sure what you had to do. Forget looking for a tutorial on YouTube. Soon enough, you might be able to put on a pair of AR glasses or contact lenses and then look at the engine. With the help of a bit of AI, the software will analyze the problem and then show you exactly what you have to do, and then give you feedback on whether you're doing it right. How about a city guide that doesn't just show you the best restaurants and nightlife on a map, but will point it out to you in real time with menus and reviews appearing next to them? And instead of seeing advertising billboards in the city, your AR glasses will show you virtual adverts tailored for you, which means it's got big potential for advertising as well. Or what about doing some online shopping for clothes and see yourself wearing them, even though you've never been anywhere near them? Getting a preview of how furniture will look in your room, even though it's still in the warehouse, or conference calling someone on the other side of the world and having them appear on your couch. And these are just a few things AR could be bringing to us soon.
The main goal of the SDG 9 related infrastructure is to facilitate sustainable and resilient infrastructure development in developing countries through enhanced financial, technological, and technical support to African countries, least developed countries, landlocked developing countries, and small island developing states by 2030. The basic facilities, services, and installations needed for the functioning of a community or society, such as transportation and communication systems, water and power lines, and public institutions, including schools, college, hospital, post offices, etc. Modern day thinking suggests that other forms of infrastructure exist. These include technology and human infrastructure. Technology infrastructure consists of science, engineering, and technical knowledge available to the nation's industries. Human infrastructure considers education and training as a form of investment that will generate future benefits.
For hundreds of years, European explorers searched this coastline for California's fabled cities of gold. And yet, the treasure hunters kept missing the entrance to one of the world's finest natural harbors, the Golden Gate. It was hidden for so long because this is what explorers would see: a rocky shoreline, turbulent waters, and no hint of an opening. The bay opens up 3 miles back from the Pacific. Its entrance is only a mile wide, hard to spy from the sea. In fact, it was a land expedition that finally spotted the entrance from nearby hills, 230 years after the first Spanish ship sailed by. A 19th century army captain gave the passage its name, Golden Gate. Today, anyone entering the bay by sea must pass under San Francisco's most iconic structure, the Golden Gate Bridge. It's hard to imagine now, but before the bridge was built, the only way across the bay was by ferry. Boats carried 50,000 commuters a week. It's no wonder the biggest opposition to the bridge came from ferry boat operators. But at last, in 1930, the voters of San Francisco gave engineer Joseph Strauss the green light. Strauss said he dreamed of building the biggest thing of its kind that a man could build. His design ranks with the Empire State Building and Brooklyn Bridge as a symbol of American progress and ingenuity. The entire bridge is 1.7 miles long. Its towers rise 746 feet above the bay. To build a similar bridge today, it would cost over $1 billion. In 1937, the Golden Gate made its debut as the world's longest suspension span. Its 2 main cables reach 4,200 feet from one tower to the other. It's called a suspension bridge because the roadway hangs from the cables. The cables are held up by the 2 towers and anchored at either end of the bridge. And while most bridges at the time were painted black, the Art Deco Golden Gate was painted a reddish orange to catch the light and make it stand out in fog.
The Golden Gate Bridge is a 1.7-mile long suspension bridge that took over 4 years to build and link San Francisco and Marin County. It was opened to vehicular traffic on May 28, 1937. The bridge's 2 towers rise 746 feet and the bridge crosses Golden Gate Street, which is about 400 feet. The Golden Gate Bridge was completed at a construction cost of USD 438 million, making it one of the world's greatest infrastructure. Thank you very much for listening to me.